Hello, this is Craig Hartman with Energy Management Corporation. Energy Management specializes, as you see on the screen, in motors, drives, and generators. And we have a great deal of field service and specialize in harmonic, arc flash studies, and so forth. Today, we're going to have a very short presentation on the use of copper versus aluminum wound transformers. We get a lot of questions on that. And so we're going to discuss that a little bit. So when we say a copper versus an aluminum transformer, of course, a transformer is built using a core of iron, generally silicon grain-oriented iron that basically I think of as a conductor of magnetic flux. Then we have the windings. The windings can be made of copper or aluminum. And then we have the bracing in there, and then we have some kind of cooling. It could be an air-cooled, in which air flows through and cools the copper and aluminum and steel. Or it could be an oil-based transformer in which you have mineral oil or some other kind of cooling fluid. So obviously, when we talk about copper versus aluminum, we're only talking about the windings. And so as a non-transformer manufacturer, but someone who uses and supplies a lot of transformers, we're going to give you a third party's view of this. So in house wiring, you can see there's some aluminum wires and some copper wires, and aluminum wires in these types of installations can end up developing an aluminum oxide, and it has caused some of those terminals to become hot. And so in house wiring, and we're talking about the wiring that you're seeing there to lights and receptacles and things of that sort, the National Electrical Code asks you to use copper. And so in all modern houses, at least in the United States, complying with the NEC, they use copper wiring. If you're outside the United States and listening to this, then your country may have different standards. But here's the service entrance wiring. And so this is the wiring that would come from the utility into your house, into the main panel. Pretty much all of that wiring is aluminum. And service entrance cables made of copper will typically not be available very easily. I remember once I was buying some of this, I was building a house, and I called the distributor. I said, just as a point of interest, what would a copper service entrance conductor cost? And there was this pause on the line like, you know, what are you, a moron? And he said, well, we don't have copper service entrance cables. He said, we could probably get some for you, but I would have to check on that. That would be a special order. So pretty much all of these have switched to aluminum, and they're fine. They work just fine. Let's look at the resistivity of some metals. Silver has a resistivity of 1.6 times 10 to the minus 8th ohm per meter, or you could say ohm per meter squared, or I'm not saying this right, it's ohm meters. Or you could say it's ohm meter squared per meter, which might make more sense, but that's the same thing. Copper is 1.7, aluminum is 2.8. So if you look at that, you say, well, gee, I'd like low resistivity, I'll use silver. Well, nobody uses silver because it's too expensive. And traditionally, we've used copper because it's a better conductor than aluminum. However, if you just make the wire a little bit bigger, you can basically get the same resistance in aluminum as you get in copper. You just need to use a larger wire. And as you know, if you ever look at ampacity tables in the National Electrical Code, you'll see that aluminum wires of a certain size are going to have less ampacity than copper of that same size. But once you have an equivalent aluminum to copper with the same resistance, then they basically perform the same, they have the same losses, and it's not really a problem. So here's a transformer that has copper wires. You can see the kind of reddish color of copper there. There is a misconception that distribution transformer with copper windings are more efficient or more reliable, or they have a higher short circuit withstand. And so we're going to just talk about that for a moment. So if you look up on the internet or you have a copper transformer manufacturer who's trying to tell you that his transformer is based of copper and therefore is better, they will generally tell you that copper is harder, it's more ductile, it has less creep, it's less expensive to manufacture, and is smaller than an equivalent aluminum transformer. Now, that less expensive to manufacture is almost never true. People have switched to aluminum primarily because the aluminum is less expensive to manufacture. Let's look at some of those other claims. First of all, efficiency. The efficiency of a transformer is based on its core losses and on its conductor losses. So the core losses depend upon the iron core, that silicon grain-oriented steel inside the transformer. They have nothing to do with copper or aluminum, and therefore they basically are equivalent. An aluminum wound transformer, if you use the same conductor material, would be less efficient than a copper. But as I mentioned, if you just make the aluminum conductors a little bit larger, then it would have the same efficiency as a copper wound transformer. So when someone's looking for the best efficiency in a transformer, typically they'll say, well, we're going to evaluate transformers based on this many dollars per kilowatt, no load losses, and that tells you the efficiency of the core, and this many dollars per kilowatt for full load losses, and that gives you the efficiency of the windings as well as the core. And then a transformer manufacturer will optimize their transformer design in order to come up with the best transformer that's going to evaluate the best in your evaluation. Turns out that doesn't really have a lot to do with aluminum or copper. You can make the aluminum conductors bigger, or you can make the copper conductors bigger. You can make both have equivalent efficiencies. So basically, I would say this is sixes. Next is your reliability. What determines the reliability of the transformer? Well, mostly reliability is determined by the insulation system and how hot you run the transformer. So the better your insulation, the higher the BIL rating, that's your basic impulse insulation level, the longer that transformer is going to last and the better it's going to withstand surges from the line. The hotter you run the transformer, obviously, the lower the lifespan of that transformer. Well, you can use the same insulation system, you can use the same heat rises in a copper or aluminum transformer, and therefore there's really no advantage to one or the other. Finally, a short circuit strength. A transformer withstand rating is determined by the geometry of the conductors. For instance, a round conductor, and I'm talking about a round coil, not the conductors themselves, but a round coil is going to be easier to get a high withstand rating on it, high short circuit withstand rating. But most transformers, smaller transformers, are built with rectangular cores. And the reason they do that is to decrease the size of the transformer. They have proved to both have equivalent reliability if the transformer manufacturer braces each one of them for the equivalent short circuit withstand rating. So it turns out that really doesn't have a lot to do with aluminum or copper either. It depends on the transformer design and the bracing. And so we wouldn't give one or the other the benefit. Now, transformer size, there's no doubt that a coil can be built smaller with copper versus with aluminum, but size is typically not based so much on the coil size. If you look inside of a transformer, it may be based on the geometry of the coil. In other words, is it round versus rectangular, how tightly packed those coils are. It's based upon the bracing. If you look inside of a transformer, you typically have some big steel braces that try to keep that transformer tight and help it withstand short circuits. And it's built on the heat withstand. So obviously, the more surface area you have, the easier it will be to cool. And if you have a liquid cooled transformer, like with mineral oil, the larger the transformer is, the more tubes you have in the radiators, the more cooling capability you are going to have. And so in theory, an aluminum transformer will be a little bit easier to cool because the conductors are larger. But in practice, either one cools just fine. The transformer manufacturer builds that thing to run at a certain temperature rise. And whether it's copper or aluminum, it will run at that temperature rise. And so here again, I wouldn't say one is better or worse than the other. Now, popularity, I was the director of engineering for Geneva Steel. And before that, I was the a district engineer with Westinghouse. Westinghouse at the time was a huge manufacturer. They sold out mostly to other manufacturers, mostly to Eaton and to ABB. But they were a huge manufacturer, and there came a period of time when aluminum was cheaper than copper. And so Westinghouse moved all of their transformers, their standard distribution transformers, to aluminum. So did GE, so did Cooper. Everybody pretty much went to aluminum. And obviously, as that change was made, there were people wondering and asking questions about whether that was going to decrease the reliability of the transformers. Well, it turned out that was kind of a nothing to us. The aluminum transformers work just fine, and they have the same warranties, they have the same specifications, and over the ensuing decades, our aluminum transformers turned out to be equally reliable in use. As you know, transformers are pretty reliable devices. They tend to last for decades. And so for this reason, everyone switched to aluminum, and that is their standard design. And they can build you a copper, but it tends to be extra cost and special order because their standard design is aluminum. And that pretty much is still the situation with your high volume, large, very popular manufacturers. So the summary is copper wound and aluminum wound transformers can be built to have the same efficiency, the same short circuit withstands, and the same reliabilities. And therefore, we see no reason really to prefer one over the other in these distribution transformers and transformers that are a standard part of a variable frequency drive or such. Because aluminum is the standard, mostly what we have sold in the past is aluminum transformers, and they generally are better cost-wise, and it is the manufacturer's standard design. And so I would prefer a standard aluminum wound transformer than I would a special one-off type of copper wound transformer. But if the manufacturer's standard design was copper, I'd be fine with that. I really don't have a real preference of one over the other. I would just say, I want your standard design. I want it to have the equivalent specifications that I desire. And that's what I would choose. Incidentally, we sometimes use copper cables and copper wiring. Sometimes we use aluminum. That doesn't make any difference because whether you have an aluminum wound transformer or a copper wound transformer, either one, the lugs can accommodate copper wire or aluminum wire. And so that really isn't an issue here either. So as a summary, I would say go with the standard and don't be worried too much whether it's got copper or aluminum wiring.